Hi guys, so today I'm going to be talking about few statistical tests that use the hypothesis testing framework. What is a hypothesis test? If you remember, we had two statements, a null hypothesis and an alternate hypothesis. We had a test statistic that gives a mathematical form to the statement that we would want to check, and we look at the p-values, and if the p-value is less than 0.05, we reject the null hypothesis, else we fail to reject the null hypothesis. So in my last video, I've taken the example of a candy bar with the average number of nuts. The null hypothesis was the average number of nuts in each candy bar was 5. So the test statistic here is the average, or the average number of nuts. So that is an example of a t-test. So a t-test is a test, or is a hypothesis test that is used to compare mean of something. It is used to compare either the mean of something against a value, like in my earlier example it was mu equal to 5. So we are comparing mu with 5, or it is used to compare two means of two different groups. T-test comes in three different forms, and the first type is called the one sample t-test. One sample t-test is simply comparing the mean of something to a value. So the null hypothesis here would be mean of something is equal to some value, and accordingly we look at the p-values and reject or fail to reject the statement or the null hypothesis. That is called a simple one sample t-test. Next comes two sample t-test. In a two sample t-test, we are comparing the means of two variables. So for example, say there is a chocolate candy bar and an oatmeal candy bar. So the null hypothesis would be that the average number of nuts in the chocolate candy bar is equal to the average number of nuts in the oatmeal candy bar. And we check if the averages in both the groups are same or not by running the hypothesis test, looking at the p-values. If the p-value is less than 0.05, then we reject the null hypothesis and we can claim that the number of nuts in chocolate and the number of nuts in oatmeal candy bars are different. So if we are comparing means of two different groups, that is called a two sample t-test. The two sample t-test again has two different types. The first type is called student's t-test. The student's t-test simply assumes that the two groups have equal variances. That means the variance of the number of nuts in the chocolate candy bar is assumed to be equal to the variance of the number of nuts in the oatmeal candy bar. So if we make this assumption and run the t-test, it is called a student's t-test. Or a student's t-test is run when we know that the variances of the both groups are same. Next is Welch two sample t-test. That doesn't make any such assumptions. So if we don't know the variances of the two groups and maybe the variances are not equal, then we can simply run a Welch t-test. So that is about the two sample t-test. And finally, we have the paired t-test. Paired t-test simply compares the mean of a variable with the mean of a related variable, or the mean of a variable in two different times. Say we are comparing the heights of men in Australia in 1990 against the height of men in Australia in 2020. So in some way these two groups are related. So if we are comparing the means of two related groups, that is called a paired t-test. So these are the different forms of t-test which are used to compare means of two groups or one group against a specific value. But there are some important points to remember when we are running a t-test. The first point is t-test works well only when the sample sizes are less than or equal to 30. If we want to run the test for larger sample size, this doesn't give really authentic results. So the first point to remember is that t-test is used only when sample sizes are less than or equal to 30. The second assumption is that t-test assumes that both the groups that we are comparing the means of have a normal distribution. The last point to remember about t-test is that a t-test can work even when the underlying standard deviation or the variances of the groups are unknown. So if you remember in students t-test, I've mentioned that it assumes that the variances of both the groups are equal. But that doesn't mean that we should know the values of the variances in both the groups. So to run a t-test, even if we don't know the values of the variances of the groups, it is alright. So t-test works well only when the sample size is less than or equal to 30. A t-test assumes normal distribution of the groups we are comparing. And finally, to run a t-test, we don't need to know the standard deviation or the variance of the groups we are comparing. Next comes z-test. Z-test is also like t-test where we are comparing the means of two groups. The main difference is that in a z-test, we can work with sample sizes greater than 30. But just like t-test, even this assumes normal distribution of the variables we are comparing. And in a z-test, we need to know the standard deviation or the variance of the two groups we are comparing. So if we are dealing with data whose sample sizes are greater than 30 and whose variances we know, then we use a z-test. And if we are comparing means of two groups where we are using a sample size less than 30 and we don't know the variances of those groups, then we use a t-test. Next is the f-test. F-test is also a statistical test, except the test statistic here is not mu. So we are comparing the standard deviation or the variances of two groups. So f-test is used to compare the variance or the standard deviation of two groups. F-test also assumes a normal distribution of the groups we are comparing. The next one is called Anova. It is short for analysis of variance. So we know that a t-test is used to compare means of two groups, and an f-test is used to compare the variances of two groups. Anova is used to compare the means of more than two groups. So if our null hypothesis looks something like this, so if we have more than two groups to compare, then we use an ANOVA. The test statistic here is also mu or mean. So how does this do that? To do that, it simply uses the f-test. So it computes something called the f-statistic. That is simply the ratio of between group variance to the within group variance. And to compare variances, we use f-test. So to calculate these values, we are using f-test. But how does this ratio help us check if the means of these groups are same or not? So what we do is, if between group variance is high and if within group variance is low, it means in each group, the elements in each group are very similar. Hence, the within group variance is low. Variance is how much a data point is deviating from the mean. So it's not deviating a lot. So it's more or less the mean of that group. All the points in that group is same. And between group variance, if it is high, it means the mean of this group, all the points within this group is same, but there is another group whose within group variance is high, that is all the points within this group are almost same or have similar means, but the means of these two are different because between group variance is high. So if this ratio is high, it means there is high modularity in the data, or we are able to form clusters in the data. If we can say that, we know that mu A, mu B, mu C, mu D are not equal because between group variance is high, so we can't say that they are equal. But what if between group variance is low and within group variance is high? If within group variance is high, we can't say that the ball here, the points in this ball have similar means because the within group variance is high and between group variance is low. It means all the groups are almost merged and there is no separation between them. So within group variance is high and between group variance is low. So we can't really modularize the data. That means we can say that the means of all the groups are same. That means by calculating this F statistic using the F test, we are able to check if the means of two or more groups is same or not. So Anova is just an extension of t-test where we are comparing the means of not just two groups but multiple groups, and to do that we are using the F test. So we've looked at Anova, and let's look at a data set that looks something like this. This column is the number of nuts in the candy bar and this column is the group. This looks like a real world data, and if you look at this data, this is a numerical variable and this is a categorical variable. If we are able to say that means of all the groups are equal, it means that this variable has got nothing to do with the mean of this variable. That is, variable A is not really related to B, because if it is related to B, if we are changing the group, that change should also be reflected in the mean. But if means are equal, it means that by changing this group, there is not a lot of change in the mean of the number of nuts, or there is not a lot of change in the numerical variable. So there is no relation between these two. But if the means are not equal, that is by changing the group, if the means of the number of nuts are changing, it means that there is some relation between that categorical and continuous variable. So simply put, Anova is a statistical test that is used to check if there is any correlation between a continuous variable and a categorical variable. Everything in a nutshell, we've seen what a t-test is. A t-test is used to compare the means of two groups. We have a one sample t-test that compares the mean against a particular value. We have two sample t-test that compares the means of two groups. And in that two sample t-test, we again have students t-test that assumes same variances in both the groups we are comparing. And we have Welch t-test that doesn't make any such assumptions. And finally, we have pair t-test that is used when we want to compare groups that are means of the groups that are related. And a t-test works only when the sample size is less than 30. A t-test assumes normal distribution of the groups we are comparing. And to run a t-test, we don't need to know the variance or standard deviation of the groups we are comparing. Next comes a z-test, which is also used to compare means of two different groups, except it also works for sample sizes greater than 30. It also assumes normal distribution of the groups we are comparing. But in a z-test, we need to know the underlying standard deviation or variances of the groups we are comparing. Next comes an F-test, which is used to compare the standard deviation or variances of two groups. The test statistic here is not mean but standard deviation. It also assumes normal distribution of the groups they are comparing. Next comes Anova, when we want to check the means of more than two groups. So to do that, Anova uses an F test to compare between group variance by within group variance, and if this value is high, null hypothesis is rejected. And similarly, this is in another way used to check the correlation between a continuous and a categorical variable. So that is all for today, guys. Thank you so much.